Welcome back. So in our previous video, we learned about classical bits and quantum bits. Now let us represent single qubits on a Bloch sphere. The Bloch sphere representation of a single qubit. One can visualize the different states of a single qubit. So the single qubit state ket psi is equal to A ket 0 plus B ket 1. So this can be written in terms of spherical polar coordinates theta and phi. So the variables theta and phi are angles in spherical polar coordinates. You can see the diagram there. R is the distance from the origin of the point, and theta is the angle made by the vector, the position vector, with respect to the z-axis, and phi is the angle made measured from the x-axis to the projection of the vector in the xy plane. So equation 6 represents the general qubit state, a single qubit state in spherical polar coordinates. So for different values of a and b, we have different states for a single qubit. Now let us represent these on a Bloch sphere. So by putting theta is equal to 0, you get psi is equal to 0, and by putting theta is equal to pi, you get psi is equal to 1. So these states 0 and 1 are situated where theta is equal to 0 and theta is equal to pi. We will visualize them shortly. So clearly you can see the normalization condition is satisfied even here. Mod a squared plus mod b squared happens to be equal to 1. So here it means the length of the vector psi is fixed and is equal to 1 always. The state psi, ket psi, is a point on the surface of a sphere of unit radius. So this is a Bloch sphere, and you can see the vector ket psi is sitting on the surface of the Bloch sphere with the sphere located at the center of the coordinate system xyz, and in spherical polar coordinates you have two more angles theta and phi. The distance r is fixed and is equal to 1. Now let us calculate the positions of different states for a single qubit on the Bloch sphere. For different values of a and b, we have the following states. So we are considering these states, the popular ones: psi is equal to 0, psi is equal to 1, or 1 by root 2 ket 0 plus ket 1, or 1 by root 2 ket 0 minus ket 1, 1 by root 2 ket 0 plus I ket 1, and 1 by root 2 ket 0 minus I ket 1. So let us visualize these different states on the Bloch sphere. So some basic math is needed to evaluate. You have to know the values of sine and cosine functions for different angles. Say 0, pi by 4, 45 degree, pi by 2, 90 degree, pi is 180 degree, 3 pi by 2 is 270, and 2 pi is 360 degrees. And we also make use of the Euler's formula. E to the ix can be written as cos x plus I sin x. So starting with the first one, ket psi is equal to 0. How do I visualize this on a Bloch sphere? Comparing with the standard qubit equation, so comparing equation 8 and 9, so one can say that the cos theta by 2 has to be equal to 1, or e to the I phi sin theta by 2 is equal to 0. You may use any of them. You will end up with theta is equal to 0 as the solution, which is the north pole. When theta is equal to 0, we need not specify angle phi because there is no projection of the vector in the xy plane. And this is where it is. You can see the state ket 0 situated at the north pole of the Bloch sphere. Next, we consider psi is equal to 1. Again, comparing it with the standard qubit equation, comparing 10 and 11, 1 has, so clearly we see that there is no ket 0 in equation number 10. So cos theta by 2 has to be equal to 0 because that term isn't there. So that coefficient has to be 0. So cos theta by 2 is equal to 0 implies theta by 2 is equal to pi by 2, or theta is equal to pi, which is the south pole of the sphere. Again, when theta is equal to pi, there is no projection of the vector in the xy plane, so phi need not be specified. So here is ket 1. So at the south pole of the Bloch sphere, you can see theta is equal to pi, which is indicated in the diagram. Next, we consider the superposition of 0 and 1. Ket psi is equal to 1 by root 2, ket 0 plus ket 1. So comparing this with the standard qubit equation, so the coefficient cos theta by 2 has to be equal to 1 by root 2 by comparison. So which implies we know that cos x is equal to 1 by root 2 when x is equal to pi by 4. So from which we get theta by 2 is equal to pi by 4, or theta is equal to pi by 2, which is 90 degree. It means it is located in the equator. But where in the equator? So for which you make use of the other coefficient, e to the I phi. Sin theta by 2 has to be equal to 1 by root 2 by comparison of 12 and 13. And you know that something has to be equal to 1 by root 2. The cos of cos theta by 2 was found to be equal to 1 by root 2, and theta was equal to pi by 2. Substituting that here, you have e to the I phi sin pi by 4 is equal to 1 by root 2. So sin pi by 4 is nothing but sin 45 degrees, which is 1 by root 2. The root 2 gets cancelled, and e to the I phi is equal to 1. Now to find out the value of phi, we make use of Euler's formula. E to the ix is equal to cos x plus I sin x. So by comparison, you get cos phi plus I sin phi has to be equal to 1 plus 0i, because there is no imaginary part and the real part is equal to 1. So by comparison, cos phi is equal to 1 and sin phi is equal to 0, both of which imply that phi has to be equal to 0. So theta is equal to pi by 2 and phi is equal to 0. So plotting this, we have the position of the state 1 by root 2 ket 0 plus ket 1 situated there towards you near in the equator. Similarly, one can find out the Bloch sphere representation for the state 1 by root 2 ket 0 minus ket 1. So again, compare it with the standard equation. Just as before, cos theta by 2 has to be equal to 1 by root 2, implying theta is equal to pi by 2 situated in the equator. Now to find out phi, this time we need it to be equal to minus 1 by root 2 because of the minus sign in equation 14. And substituting theta is equal to pi by 2, sin pi by 4 is 1 by root 2. Again, they get cancelled. This time, e to the I phi is equal to minus 1. Again, make use of Euler's formula, compare them. We require cos phi plus I sin phi is equal to minus 1 plus 0 times I, because there is no imaginary part. So this implies cos phi is equal to minus 1 when phi is equal to pi, or sin phi is equal to 0 also implies phi is equal to pi. So this is situated behind where it was before in the equator. So we are just substituting the values of phi and theta and finding out the positions of the different states. Now let us consider a little complicated one. 1 by root 2 ket 0 plus I ket 1. Just as before, you get theta to be equal to pi by 2 situated at the equator. Now this time, uh, equating the coefficient for ket 1, you have e to the I phi is equal to I. It is imaginary, so use the Euler's formula. E to the ix is equal to cos x plus I sin x. This time there is no real part, so cos phi plus I sin phi has to be equal to 0 plus I. So comparison tells us that cos phi should be 0. We know phi has to be equal to pi by 2 for cos phi to be equal to 0, or sin phi is equal to 1 also implies phi is equal to pi by 2. So this is the position of the state 1 by root 2 ket 0 plus I ket 1. Similarly, one can do it when there is a minus sign. Theta is equal to pi by 2, and use the other coefficient, find out what is e to the I phi, use the Euler's formula. This time you have cos phi is 0, sin phi is minus 1. That happens when phi is equal to 3 pi by 2 or 270 degrees, and that is where the Bloch, the representation of the vector is. So we have all the states represented on the Bloch sphere in this fashion. Ket 0 and ket 1 are in the north and the south poles respectively, and the remaining states all on the equator. There are an infinite number of single qubit states because A and B can take any value, any finite value. So every point on the Bloch sphere represents a single qubit state.